Let's take a look at multiplying fractions. And first I'll write down the formula. Now I'll give us some practical tips. So multiplying fractions. And it goes like this. If we have a over b times c over d, typically these represent integers, then what we do is we multiply the top parts together, the numerators, a times c, and we'll multiply our bottom parts together, our denominators. So we got b times d. Now you're not restricted to just two fractions, you could have three here. And same idea, you multiply your tops together, multiply your bottoms together. So our steps. First step is to simplify, if I could spell, simplify all fractions. And we're going to see more about what that means with examples. Numbers, it means if you got a number on top and a number on the bottom that you can both divide by the same number, do so. And if you got x to a power over x to a power, again, one's on top, one's on the bottom, then you subtract the exponents, and you have x to that power where a larger exponent was, or whatever variable you're dealing with. And then after we simplify your fractions, we'll multiply the tops, and we'll multiply the bottoms. So multiply the numerators and the denominators. Okay, now you notice I don't have step 3 here of simplify your final answer or reduce, because if you've done a good job in step 1, then you don't need to do that. Let's take a look at this problem. We got 6/8 times 14/24. And step 1. Our first step is, when you deal with numbers, is look for a number on top, a number on the bottom. You can divide both of them by the same number. So here I got 6 and 24. They're both divisible by 6. 6 divided by 6 is 1. 24 divided by 6 is 4. And I'll always show a lot more steps than you need to. But let's see what we have left. 1/8 times 14 over 4. Okay. And again, we're looking for a number on top, a number on the bottom. Doesn't matter. They don't have to be in the same fraction. They can be. Here we got 14 and 4. Those are both divisible by 2. 14 divided by 2 is 7. 4 divided by 2 is 2. Which gives us 1/8 times 7/2. Now it looks like I can work with the 8 and the 2, but they're both on the bottom. Our guideline is one's on top, one's on the bottom. And so that's as much simplifying as we can do. So then step 2, you want to multiply your top parts together. 1 times 7 is 7. And multiply your bottom parts together. 8 times 2 is 16. So that'd be your answer. Let's take a look at our second example. We got 15 over 6 times 10 over 25. And again, our guideline is one's on top, one's on the bottom. And let me work with this first. 10 and 25. Both divisible by, this is step 1. Both divisible by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. So we got 15 over 6 times 2 over 5. Okay, so let me pick on 15 and 5 now, because they're both divisible by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. So we're going to have 3 over 6 times 2 over 1. And let me focus on the 3 and the 6 now. Those are both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And we're left with 1 over 2 times 2 over 1. And last, simplifying, is we got a 2 here and 2 here. Both divisible by 2. 2 divided by 2 is 1. 2 divided by 2 is 1. So we're going to end up with 1 over 1 times 1 over 1. And we're ready for step 2. I'm running out of room here. Multiply top parts together. 1 times 1 is 1. Multiply bottom parts together. 1 times 1 is 1. And 1 over 1 gives us 1. And that's our answer. Okay, let's look at this example. We got 6 over 9 times 12 over 14 times 18 over 24. Now again, we're looking for a number on top and a number on the bottom, and they're both divisible by the same number. I'm going to start with 12 and 24 here. 12 and 24 both divisible by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. So we got 6 ninths times 1 14th times 18 over 2. Well, here's a 9 and here's an 18. They're both divisible by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. And so we got 6 over 1 times 1 over 14 times 2 over 2. Well, that jumps out of me right there, 2 over 2. So work with those. One's on top, one's on the bottom. 2 divided by 2 is 1. 2 divided by 2 is 1. Okay, so we got 6 over 1 times 1 over 14 times 1 over 1. If it's ever 1 over 1, you could just drop that part, but I'll leave it there. And it looks like we got one more. We got 6 and 14. Both divisible by 2. 6 divided by 2 is 3. 14 divided by 2 is 7. So we're going to have 3 over 1 times 1 over 7 times 1 over 1. And now we're ready for step 2. Step 2 says multiply your tops together. 3 times 1 times 1 is 3. Multiply your bottom parts together. 1 times 7 times 1 is 7. So our answer is 3 sevenths. Let's take a look at this one. We got 8 times 3 sixteenths. When you're working with fractions, if you're adding, you're subtracting, you're multiplying, you're dividing, whatever operation might be, if one of them is a fraction, you want both of them to be fractions. Well, we can always create a fraction by putting it over 1. So I'll put the 8 over 1. And now we're actually multiplying fractions. Well, our first step. Actually, this is step 1 right here. I didn't say it, but step 1. Simplify your fractions. Well, right away I see an 8 and 16 here. Those are both divisible by 8. 8 divided by 8 is 1. 16 divided by 8 is 2. So we got 1 over 1 times 3 over 2. No more simplifying to be done there. So now we're going to go to step 2. Multiply top parts together. 1 times 3 is 3. 1 times 2 is 2. So our answer is 3 halves. Let me save this page. Okay. And it's coming up. There we go. Multiplying fractions. Page 01. Okay, let me start a new page. And let's look at our next problem. We got -6 times -7/4. I'll put parentheses to indicate multiplication. Right away I notice one of them isn't a fraction, so let's rewrite the -6 as -6 over 1. Okay, if we're going to multiply fractions, they both should be fractions. Now, step one, want to simplify. And, well, I notice here I got a 6 and 4. Those are both divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So let's see what we have left. Don't drop the negative. So we got negative 3 over 1 times negative 7 over 2. Nothing else I can simplify. Remember, our guide is one's on top, one's on the bottom, and you can divide both of them by the same number. So we go to step 2. Step 2 says multiply your top parts together. Well, a negative times a negative is a positive, and 3 times 7 is 21. And multiply your bottom parts together. 1 times 2 is 2. And that'd be your answer. Let's take a look at this problem. We got 14x squared over 6 times 2 over 49 x to the fourth. Okay, step 1. Simplify our fractions. Right away I see here 2 and 6. Those are both divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So we're going to have 14x squared over 3 times 1 over 49x to the fourth. I have a 14 here and a 49 here. Those are both divisible by 7. 14 divided by 7 is 2. 49 divided by 7 is 7. Which is going to give us 2x squared over 3 times 1 over 7x to the fourth. Now, number-wise, there's nothing else I can do. And remember, our guide is one's on top, one's on the bottom. We can divide both of them by the same number. But it looks like I got some x's. Here I got x squared, and here I got x to the fourth. Okay, so we're going to have 2 over 3 times 1 over 7. Now, how we handle the x's? If you have x to a power over x to a power, and they don't have to be in the same fraction, just one's on top, one's on the bottom, and the same variable. What you do is you subtract a smaller exponent from a larger one. So we got 2 and 4, so 4 minus 2 would give us 2, and we'll have x to this power where our larger exponent was. Larger exponent was down here, so we're going to have x to the second power here. Well, now we're ready for step 2. We've done as much simplifying as we can do, so multiply the top parts together. 2 times 1 is 2. Multiply the bottom parts. 3 times 7 is 21, and then we have the x squared. And that's our answer. Let me see if I think I can fit this next one on. Better start a new page, just in case. Okay, so let me do a file new and choose 11 by 8. There we go. And scroll up a bit, and let's look at this problem. So I got 50 xz to the fourth xz squared over 4y times 4x over 12y z to the third times 8y to the fourth over 25x. And yeah, looks right. Okay, step 1. Look for a number on top, number on the bottom. Well, here's a 50 and here's a 25. One's on top, one's on the bottom. They're both divisible by 25. 50 divided by 25 is 2. 25 divided by 25 is 1. Now let me actually show you in a problem here how you can combine them. Here's a 4 and here's a 4. Those are both divisible by 4. 4 divided by 4 is 1. 4 divided by 4 is 1. And one more. Hopefully it doesn't become too convoluted. Here's a 12 and here's an 8. They're both divisible by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. Doesn't look like green is a very good color to pick. So we're left with 2x z squared over 1y or just y times 1x or just x over 3y z to the third times, and we got a 2, y to the fourth over 1x or just x. Now let me double check myself. 2x z squared, 1y, x, 3y z to the third, 2y to the fourth, and then x. Okay. Well, here's an x, and here's an x. Since they both are x the first, I can just cancel those. Let me see. Actually, I may go ahead. Let me show you another way you can do this. You can go ahead and now, since the numbers are simplified, go ahead and multiply across. 2 times 2 is 4. That x is gone. Here's an x. We have 4 y's, y to the fourth, and we have 2 z's. And down below we have a 3. And we have no x's. We have 1 y there and 1 y there, so we've got 2 y's, or y squared, z to the third. Okay. And let me double check that. Y to the fourth, z squared, y squared. Okay. Now we just got an x on top, so that stays up on top. Here we have y to a power over y to a power. So for our y's, we'll subtract a smaller exponent from a larger one. 4 minus 2 is 2, so we're going to have y squared where our larger exponent was, which was up on top. Now for our z's, we have z squared over z to the third, subtract a smaller exponent from a larger one. 3 minus 2 is 1, so we're going to have z to the first where our larger exponent was, which is on the bottom. And then anything in the first power you can just write without the 1. So that's 4xy squared over 3z. Sometimes, instead of trying to figure out the x's and y's here, I find it easier to combine them together here. And that way I can clearly see what's going on. Yeah, I think that was our last problem. Yes, it was.